Hola and hello. I hope you're enjoying MonkeyConf 2024 so far. My name is Martin Zikmund. I'm a cross-platform developer working in open source and contributing to Uno platform, which will be the topic of my session today. I will be doing kind of a deep dive into how Uno platform works under the hood. I will pick some interesting topics that can be useful for you as a .NET developer in general. And then you can join the sessions of my colleagues Andres and Steve, who will be talking later today. We will be talking more about how you can use Uno platform to build cross-platform applications. Before we start exploring the internals of Uno platform, let's explain what Uno platform actually is. Uno platform is an open source solution for building native .NET cross-platform applications for Windows, Linux, macOS, Android, iOS, and the web using WebAssembly. It's free and open source, available on GitHub, so anyone can contribute and file issues and make pull requests. And we strive to be a single code-based solution. So you as a developer write your application just once, and it runs across all the targets that you can imagine. The platform itself consists of the core framework, which is Uno platform, and many additional first-party and third-party extensions. It includes things like toolkits, which are additional controls that you can use in your applications, some extensions, which are building blocks for your application, but also it includes our new Uno Platform Studio, which is a productivity suite of tools that allow you to make your development faster and more efficient. And it now includes a new offering called Hot Design, which is our live designer that shows up right in your application's UI, and you can design your application as you are executing it on the target device. And Steve, my colleague, will be showing this live in his demos later during MonkeyConf, so definitely tune in for his session. Uno platform strives to be a cross-platform replacement for Windows UI library. We are offering the same API surface as WinUI, Windows UI library on Windows. So it has the same namespaces, the same methods, the same classes, the same events, and so on. So you as a developer are essentially just writing a Windows application that then compiles against Uno platform instead of WinUI on all the other targets. And you are shielded away against all the platform specifics on each of the targets. This is super efficient because you just have to write your application once and you don't have to learn any platform specifics. Because the Uno platform codebase is super extensive and super complicated, I picked just 3 topics that I will be touching on mainly today. And if you want to learn more, I will be pointing you to some interesting parts of the codebase as well at the end of the session. But the topics I will be discussing today is our custom MSBuild SDK that we use to build to allow our customers to more easily update to new versions of Uno platform and to make their project files simpler. We also have a lot of source generators, so I will be touching on how we use source generators to compile XAML code into C#. And also, finally, I will touch on how our CI pipelines look, because they are very interesting, very complex, and do a lot of things. So these are the main topics I will be talking about today. But first, I will be jumping into GitHub to show you how our repositories look and how you can kind of navigate yourself throughout our code bases. So here is the home of Uno platform on GitHub. You can see it's actually a GitHub organization at github.com/Uno platform. And this is the place where you can find all the repositories that are available and open sourced from Uno platform. And you can see it's actually now 91 repositories that are publicly available, so you can browse the code, you can learn from it, you can also contribute and make pull requests, which is something that we always welcome. So if you are interested into cross-platform development and you want to learn and contribute to open source, that we will be very happy to help you get started and contribute to some parts of Uno platform. Uno platform, as I mentioned, is an ecosystem which contains many things, not just the internal framework itself, but many things on top of it. So you can see that in addition to the main framework, which is Uno platform, You have many things like Uno extensions, which are additional building blocks that you can use in your applications. There is Uno Toolkit, which are UI controls that you can use in your applications. There is Uno templates, which are the solution templates that you can start your application from. And many other things like Gallery, which is our sample app, and so on. So you can browse this, you can learn all about the different components of Uno platform, but the main source that we will focus on today is Uno platform itself, which is hosted at Uno.platform/Uno. This is the main repository of Uno platform. It's very huge. It currently sits at 34,000 commits, and it's increasing every day because we are making pull requests and the community is making pull requests, and it's very alive, so you can see a lot of activity happening here. This is the place where we host the source code of the core framework itself, which means a framework that handles running your application across Windows, Linux, macOS, Android, iOS, and WebAssembly all at the same time. And you can see here all the code, you can file issues, you can create pull requests, and you can participate in discussions on Uno platform. The source code is really huge. It consists of many sub-solutions. Actually, we have solution filters that allow you to pick specific area that you are interested in. So you can focus specifically on desktop targets via the Skia solution filter. You can focus on WebAssembly, you can focus on Windows, you can focus on mobile targets, and you can pick this to just make the load on Visual Studio lesser, because when you try to open the whole solution in Visual Studio, it is bound to freeze because it's kind of a too large solution for it to handle, and it really takes a lot of time for it to actually load up everything. And there is a lot of projects as well. You can see a lot of projects. The main ones that we are interested in is Uno UWP, which is kind of the internal framework that handles non-UI APIs. And then is Uno UI, which handles the UI layer of Uno platform, which is the kind of counterpart to Windows UI library. And now, from the topics that I picked, let's start with Uno.Sdk. When you create a new Uno platform application using our wizard, you can see that the created application is very simple. It's a single project application which contains all the platforms that you have selected. And its CSproj file is super simple. You can see it's just some metadata about your application and the target frameworks that you are targeting. And now, all the magic that makes this work and that takes care of all the platform specifics, all the potential Visual Studio workarounds that we have to apply, because Visual Studio often has unexpected bugs and issues with new updates, and all the things that that we have to take care of are hidden in our custom MSBuild SDK, which is called Uno.Sdk. This is super beneficial because before, if you've seen our CSproj of our application, it was much more complex. It had to contain some workarounds that actually people had to apply themselves, because with each update of Visual Studio or each update of Uno platform, we had to make some changes, and those changes people had to apply themselves using some specific steps that were described in our documentation, which was definitely not as user-friendly as now. Now, when you update to a new version of Uno.Sdk, which is a single NuGet package that's offered on NuGet, you can actually see here, if I go to nuget.info, which is, by the way, a Uno platform WebAssembly application that allows you to browse NuGet packages on NuGet, you can see that Uno.Sdk is basically a NuGet package which offers SDK and some targets, and it's just a NuGet package that you can install in your solution. And we apply it via global JSON, where you can specify the version of a specific MSBuild SDK. So when you update this single location, this single version, it updates all the dependencies of Uno platform, gives you the latest version of Uno framework and all the necessary dependencies of that. And finally, also updates the Uno.Sdk, which provides the additional things like workarounds and props and targets that are required by Visual Studio. So now, let's see. This simple file is actually very simple, very readable to any developer who is using Uno platform. But what happens when MSBuild actually runs and expands this into the full version of what this Uno.Sdk provides? So let's actually, I will show you here. You can run this nice command, .NET build, with additional parameter, which is --pp preprocess.xml or whatever name you want to provide it. And this preprocess parameter will make sure that when you run this command, it will not actually build, it will just generate this XML file which contains the expanded version of all the SDK that your project is using. So in our case, it's expanding what Uno.Sdk contains. And you can see that instead of those 28 lines of code that you actually see as a developer, Uno.Sdk, when expanded, contains over 22,000 lines. And it's just not just Uno.Sdk, but also it contains all the required things from Microsoft's SDK, so Microsoft.NET SDK or Microsoft.NET SDK.web. And it all expands using the preprocess command. So now instead of seeing all the imports that MSBuild does, you see everything in a single expanded file. So it's very, very large. But if you search for, let's see what our application is named, blank Uno app. So let's search for blank Uno app in that file. You can see on line 401, okay, so that's NuGet props, but let's search more. Actually, let's search for something like this, the whole line there. So if we search for that line, you can see that inlined in that whole big file at something like 3000th line is your CS project itself. So what MSBuild actually does, it first expands all the props files from the imported SDKs. So the props files, actually I will show you here, the SDK consists always of a props file and a targets file. So props are expanded before your CSproj file and targets are expanded afterwards. So now these are the props, but if I search for this, then you have your CSproj inlined here. And after your props, we are the MSBuild is inlining the SDK targets from Uno.Sdk. So now this is all the targets that are processing what happened. So this is just a simple explanation of how MSBuild SDKs work. And you can actually build your own MSBuild SDK if you want to. If you have something like microservice infrastructure in your company, or if you have multiple different applications that are always commonly setting the same things in CSproj, or you have some common targets that you want to reuse across your applications, then this is a great way to do it. You can create your own SDK, publish it on NuGet or on your internal package feed, and then just consume it from all your applications and use that code without having to actually copy and paste the same thing all over again, because this is error prone. And just reusing an SDK is much more safe and much more reliable. So now let's look at some of the benefits that our custom SDK can provide by virtue of being MSBuild SDK. So let's search for something like .xaml. And if I search a little bit more, you can see that, for example, Uno Platform's SDK automatically includes all the assets in your application. So PNGs, BMP files, JPEGs, and so on. It also includes XAML files, so your controls, pages, windows, and also resource files. So you don't have to include anything in your CSproj file. It remains clean, and all those files are automatically included once you add them into your project. So super useful, super clean result. In addition, we can also do platform specifics. So for example here, instead of having to write #if Android, #if iOS inside of your source code, you can have actually platform-specific C# files. So for example, here, if you write something .ios.cs, so if you name your C# file something.ios.cs, it will only be compiled on iOS. And the same goes for .android and so on. So this way, you don't have to do anything to keep your platform-specific C# files compiled only for specific platforms, except for adding that suffix to that the C# file. And it's all done for you automatically by the Uno.Sdk. So it's all automatically recognized, and those files are removed from compilation on non-Android platforms and are compiled on Android platforms only. So this is a very cool, very useful feature. Now, what also is very useful is updating to new versions of Uno.Sdk. Because before, if you had wanted to update to a new version of Uno platform, you had to update many packages because there are many dependencies of Uno platform. And that is a problem, especially because you have to know which versions of Uno platform are compatible with which versions of dependencies like Uno extensions, Uno toolkit, and so on. So you have to remember all those versions that are compatible, and you have to update them manually, which is error-prone and problematic. So instead, now you just update the Uno.Sdk in the global JSON file, and you are done. And the good thing is that even if you are using some additional features like Uno Platform Toolkit or Uno extensions, it's all easily updatable as well. Because we have something which is called Uno Features. You can actually see it here in the CS_purge file. There is a section called Uno Features. If you click on this link, it will get you to our documentation, which explains all the Uno features that you can include. And each of these features comes with some additional dependencies, some additional props, and some configuration. But all of that is embedded and hidden inside of the Uno.Sdk. So now, for example, if I wanted to include authentication using MSAL, I just put this in here and save. And this will automatically do some magic to make MSAL authentication work inside of my application. And you can see if I search for it in Uno.Sdk, it actually is an item group which checks for the existence of authentication MSAL inside of the Uno features section, and it will automatically reference some package references like Uno extensions, authentication MSAL, WinUI, and so on. So all of these packages are automatically referenced, and they are referenced with the right version that's compatible with the version of Uno platform that you are using, which is super nice, super useful, and makes your life much easier and much more efficient, because you don't have to care about anything. The Uno.Sdk does it for you. So this is another example of how beneficial custom MSBuild SDK can be. Finally, there is one more interesting thing that Uno.Sdk enables, and that is custom target frameworks. Because that's something that you might have noticed when you looked at this CS_purge file. There is -Android, -iOS, -Mac Catalyst, -Windows, which is something that you can find in any MAUI application. But we have also added two custom target frameworks using the Uno.Sdk, which is Browser and -Desktop. And these target frameworks are not a standard .NET target framework. These are custom frameworks that we created so that we can have a truly single project experience where you have all the target frameworks in one single project, and the compilation generates separate binaries for each target framework. So separate binaries for WebAssembly application and separate binaries for a desktop application. And that is done using the magic of MSBuild. So we create a custom desktop target, and that set up some dependencies that are required for Visual Studio and other development IDEs to actually recognize those targets as valid. And when you do that, as the result, you can have custom targets that are actually enabled across all that enable you to build separate binaries for separate targets like WebAssembly and desktop. So it's another part of the magic that's provided by Uno.Sdk and wouldn't be possible if we had a custom MSBuild SDK. The second topic I want to touch on today are source generators, because Uno platform codebase is using them very, very extensively, and they are very important for Uno platform to actually work. And to start with a very simple example, I will use the Uno Open Sans feature, because this is a thing that was kind of problematic, because originally we were using as a default font the Seago UI font, which is the default font on Windows. Unfortunately, when you run an application, a WebAssembly application, for example, that uses Seago UI as the default font on a non-Windows target, for example, macOS or Linux, it presents kind of a problem, because you will not actually see a nice UI. You will see a very ugly default font. Actually, you can see it here. You will see like a Times New Roman kind of font, which is definitely not something that looks nice to your users. So instead, we wanted to switch to some open source font that is really cross-platform and works nice on all the targets that you can imagine. So we picked Open Sans as kind of the default replacement for Seago UI. And this required two things. The first part is to create a NuGet package that provides those font files, so those TTF files or like the TTF files that your application will include. But additionally, we wanted to make sure that when you update your Uno.Sdk, your application will automatically start using the Open Sans font if you haven't been using it before. So to do that, we created a custom source generator that takes care of it for us. And here is the source generator. It's called very aptly use Open Sans generator. And this source generator is super simple. .NET source generator is it's an incremental generator, so it's running incrementally, and it checks whether you provided the Uno default font property, and if that Uno default font property is actually of value Open Sans, it will generate this custom module initializer that on start of your assembly, it will set the default text font family feature flag to Open Sans. And this feature flag is something that's public. Anyone can set it to a custom font, but by using a source generator and module initializer, this is happening immediately when before your application actually starts, and the default text font family is set by magic automatically, and you don't have to do anything to set it yourself. And this Uno default font property actually comes from the Uno.Sdk. So if we search for this here, you can see that we are setting this in the Uno.Sdk by default. So if you haven't set it yourself, we set it to Open Sans. And if you want to override, you can definitely do that, but by default, it's set to Open Sans. In terms of complexity, the next step would be dependency object generator. In Uno platform, dependency object is actually not a class, it's an interface. So if I do my class and I call this dependency object and go to definition, you will be able to see that it's an interface, not a class. This means that all the public members that you expect to be in dependency object are actually not there directly, but are generated for you by dependency object generator. And this is important because on Android and iOS, when we want to display some UI, we want those controls and UI elements to be backed by the native UI elements like Android views or iOS UI views and so on. And this wouldn't be possible if we derived from dependency object class. So instead, It's an interface, and that interface is code generated using dependency object generator. And this generator kind of takes your class and generates a partial definition that contains all the required public and protected methods that and members that you expect to be in a dependency object. So when you kind of check the result of the generation, you can just do that in your application anytime by going to dependencies, the target you are currently using, and then going to analyzers where you can find Uno UI source generators. You can open the dependency object generator and you can see your generated class there. And if you open that, you will see what the generator actually generated. So this is a kind of long code, but it's a partial class that generates all the necessary members that you need for your dependency object derived class to work. And so it contains all the things like get value, set value, bindings, toString, data context, and so on. So this is all available for you, and now you can use those things when you're writing your code. So you can do something like get value something, so some property. So this is very useful, and it's happening automatically or magically using dependency object generator. So finally, the most complex generator that we have is definitely XAML generator, which takes your XAML files and translates them or at compile time to C#, which is super beneficial because it makes your XAML more efficient than if you were to parse those files at runtime. That would be super inefficient and super slow. So instead we compile them into C# code that is then bundled with your application. It's a super complex generator which handles many things, including bindings, including advanced cases. So it's not a simple one for sure. And you can see that in action here. So if I do create a slider control and give it the name of slider, and then data bind this text block to that slider. So I do binding element name slider path value. Now this is a data bound text block that should be bound to the value of that that slider. So now if I actually check what the XAML generator has generated for us, it should contain all these specifics. So if I search for slider, we can see here, let's expand this a little bit. I should make it full screen here. So you can see that structure of that XAML file is replicated here, but in C#, and it's generating everything that's necessary there. So there is the slider, setting its name as slider, and then there is also the data binding. So if I search for binding or set binding, here is the text block, and its text property is data bound to the value of the slider. And you can see it all here. It's just translated into C#. But this is all the magic that Uno platform is doing at the background when you compile your applications, generating a C# representation of all your XAML code, and which is then compiled with your application. And that is what is actually executed at runtime. And definitely, if you are interested in learning more about source generators and learning about how to implement one, like looking into the source code of XAML file generator or any other source generators that Uno platform is using is very beneficial because they are very complex and handle many different cases that people generally encounter when writing source generators. So it's a very good resource for learning about source generators in .NET and C#. The last topic I want to kind of touch on today is CI pipelines, and Uno platform has a very complex CI pipelines which are run on every single pull request and merged to master. And we actually have the most complex pipelines in the Uno platform repository itself, which builds Uno platform, runs all tests, runs all validations, and then even publishes those NuGet packages that are generated. So these are the most complex of all the repositories in Uno platform organization. And we actually have two main pipelines there. One is the build pipeline, the complex one, and one is documentation only pipeline. And if the only things that are changed in your pull request are documentation files and markdown files, then we don't actually build all the packages themselves. We just build our documentation website. But if you change any C# code or anything that's not markdown, then we run the whole build pipeline, which is the complex and long one. This build pipeline, as you can see, is very, very branched out and very complex. It consists of a basic setup step, which kind of sets up everything that's needed, and then runs through a build step, and then test step, and finally publishing step. And I will kind of cover things step by step or sequentially, but first starting with some, I will start with some interest. I will stop by at some interesting steps along the way to explain things. But as a general thing, the build pipeline itself is running over 100 jobs, 100 individual jobs, and you can see across many stages. And also it's executing over, right now, over 115,000 steps across all the target frameworks that Uno platform supports. So it's iOS, Android, macOS, WebAssembly, Linux, Windows, and macOS. It's all running across all the targets and validating all the things that can happen. So that protects us against regressions and makes sure that we have everything covered. Of course, regressions still happen, but if we make sure that we cover those with tests, we are protecting ourselves in the future. So we are very optimistic and very we are focusing on making as many tests as possible, and we have many different test kinds that are executed, and I will show you that in a bit. So, but starting with some interesting things that you can apply to your CI pipelines as well. First will be conventional commits. Conventional commits is a way to standardize your commit messages so that you can more easily navigate through them and also understand what they are doing. So if I search for conventional commits, you can find here the specification at conventionalcommits.org. And this specification tells you that you prefix your commit messages with some specific prefixes. So here is a fix prefix, feed prefix, breaking change prefix, and so on. And as you learn these prefixes and start using them, this will make your commit messages more readable. Not only make your commit messages more readable. So if I kind of expand this, you will see that we have those commit prefixes there: fix, chore, and CI, and so on. So you can actually know what a specific commit is doing, but also this will allow you to easily generate change logs from your commits. So here what we have is we are using conventional commits to generate a change log, and that change log is then part of our artifacts. So if I go here and click here, and actually not here, but here, and click here, I will open that changelog, and that changelog will contain all the things that we changed since the last release. So all the bug fixes, all the features that are added, and performance improvements, and so on. This is automatically generated for you. So this is a good way if you are building an open source project to provide changelogs to your customers, because it's generated for you just based on your commit messages, and you don't have to do anything else to do it. So definitely recommend checking out conventional commit specification. The second step of the CI pipeline is to generate two versions of Uno platform, kind of two flavors, so to speak. Because Uno platform started out as a counterpart to Universal Windows Platform, which is developed by Microsoft. It was a platform that allowed you to target Windows devices and Windows phones and Xbox. But they then decided to switch the course and switch to WinUI library. And the difference between these two is mainly that the namespaces of things are different. So in UWP, most controls have a namespace of Windows UI XAML controls. And in WinUI, those are Microsoft.UI.XAML controls. This difference, although it's slight, is a problematic one. So we, to preserve kind of compatibility with both UWP and the new WinUI applications, we had to create kind of two flavors of Uno platform. And you can actually see it in the source code. So if we go to the source code, I will show you how we do that conversion. So during this step of CI, we run a simple tool called WinUI revert, where we take the namespaces like Microsoft.UI.XAML and convert them to the legacy Windows.UI.XAML and so on. So this regex expression is run across the whole source code, and we generate two versions of Uno platform. And from that point on, we are kind of executing the steps in two flavors. So we build binaries for UWP and we build binaries for WinUI. And we run tests for UWP and we run tests for WinUI. So we cover both versions of Uno platform, and we generate two versions of Uno platform for users so that they can target both the older versions of Windows APIs and the newer versions of Windows APIs. Going forward, we have many tests, and we are running tests across all different targets of Uno platform. So as I mentioned, all the different platforms that you can imagine. And we are running those tests as part of a running application, actually a running app, and they are executing as embedded UI inside of a running sample application. And I have the sample application here locally on my machine. You can see this is the Windows version of that application running locally. And we have various sample pages there that validate different behavior of different controls. And this is a place where you will spend most of your time in if you are contributing to Uno platform as a developer. The most interesting part is this unit test runner, which actually executes various tests. So if I say border and run, it will test various UI-related features of Uno platform and validate everything is working as expected in your application. And this is run in CI as well. So all this is run, and the results are then surfaced as the results of these runtime tests in CI steps here. The interesting thing here is the WebAssembly tests that I will show you. If I open this actually stage, and open the jobs there, you can find there that we are building the WebAssembly application and then publishing that application on Azure static website. And this is super cool because what this allows us to do is for each pull request that is opened, we automatically output this message that tells you to visit this custom link that is generated for each PR, and this link contains the Uno sample application as a WebAssembly application that the code reviewer can check on and can validate all the changes that the developer has done and validate that they are working in the browser version of the sample application. So they can actually run all the tests there. So I can run the border test inside of the browser, and it will execute all the UI and all the tests that are relevant to the PR. So this is super useful, and you can use it for your applications as well. So if you have a web application, you can deploy it to Azure static websites as part of your PR to give people who are doing a code review a chance to validate your application that it's actually working fine. So once all of those 115,000 tests are run and finished, you can generate the NuGet packages. These packages are generated in this generate packages step. And what are we doing during this step also is to compare the generated binaries against the latest stable NuGet packages published on NuGet. So we know we didn't do any breaking changes to the public API. And we are using this custom .NET tool called Uno package diff, which kind of compares the NuGet package APIs against the generated binaries and tells you if there are any differences. And if there are, it will generate an error because you have to make sure that those changes are actually intentional because it is a risk that you could break the customers who are depending on some public API which you would remove or change. This is something that you can use yourself. This Uno package diff is open source, so you can use it in your solutions as well. Or you can use the Microsoft Code Analysis public API analyzers package, which provides a very similar functionality, even though our version is kind of more complicated and handles a little bit more scenarios so far. So you can pick either of those. But if you're making some public product that people depend on, then it's a very good idea to do such a thing, to compare if you didn't accidentally break your public API. Finally, when everything of that is done, we publish those NuGet packages that are generated either on dev NuGet or as a production package for a release branch. So that's all the topics that I wanted to cover in today's session. Unfortunately, it is too short to cover in more detail, but if you are interested to learn more, or if you want to check out some more internals and you want to browse the code or even contribute to Uno Platform, please go to github.com/UnoPlatform or github.com/UnoPlatform/Uno, and you can browse the code base there. There is many other interesting things there, like hot reload implementation. We've built our own custom XAML hot reload implementation that is compatible with Uno Platform applications across all targets. We have many non-UI APIs, including MIDI, which is musical instrument device interface, and all the sensors like light sensor and so on. So all those APIs, you can see implementations for those there. You can also find a very complex Skia-sharp rendering pipeline in our code base, or you can also learn about how to build WebAssembly.NET applications and how the internals of that work. So many things to browse there. So if you're interested in more, definitely check out our GitHub. And with that, I thank you very much for joining my session. I hope you learned something new. And if you have any questions, definitely feel free to reach out to me on any of these links. I hope you enjoy the rest of MonkeyConf, and I will see you next time. Bye bye.